Dann guten Morgen nochmal, herzlich willkommen zum zweiten Vortrag des Big Techday 22 in diesem Stream hier. Ich freue mich heute, Herrn Sebastian Schuberth zu begrüßen, der bei Bosch arbeitet und sich auch beim Open Source Software Review Tool engagiert. Sebastian beschreibt sich selber als Open Source Enthusiast und Automatisierungsfreak, hat über 20 Jahre Erfahrung in dem Bereich, sowohl in der Mitarbeit, aber auch im Management von Open Source Projekten und auch in der proprietären Softwareentwicklung. Und um das zusammenzubringen, möchte er uns heute das OSS Review Toolkit vorstellen. Ja, genau, ich würde sagen, ich übergebe einfach mal. Fragen gerne auch während des Vortrags, wenn Sie nicht zu sehr ausufern, um das Ganze ein bisschen dynamischer zu gestalten. Entweder hier direkt aus dem Publikum oder auch an unseren Slack-Manager über Slack für die Leute, die remote zuhören. Dann bitte.
Ja, vielen Dank, Katja, für die nette Einleitung. I'll switch to English now because I announced the talk to be in English. So welcome everybody who's not a native German speaker. And to repeat what was just said, if you have smaller, tiny questions, please feel free to ask them in between to have a sort of more interactive atmosphere. But if you have bigger questions, we have a Q&A session at the end. Yes, so I'm going to talk to you about the Open Source Review Toolkit, which is an open source project that I founded about 5 years ago. But before we go into the details, since we have quite some time, allow me to talk a bit about myself, so you know who you're dealing with. So I studied computer science at the University of Braunschweig and Berlin. Back then, I focused on computer graphics and robotics and cryptology, so nothing open source related back then yet. And due to my interests in computer graphics, I also was part of the demo scene for quite some time. Does anybody happen to know what the demo scene is? Raise your hands. Okay, at least a few people. So maybe next time I'll give a talk about the demo scene and how you squeeze non-interactive demos with music and graphics into 64K executables or something like that. So the demo scene is a lot about showing off your coding skills to some extent, which is partly also true for open source, right? You show off your skills by how good you can code, how elegant your code is, how performant your code is. And of course, I'm an open source enthusiast. I do a lot of contributions on GitHub mainly. Roughly 4,000 contributions a year currently. By now, I'm very grateful to have a rather wide network of trust. I'm part of many GitHub organizations and I do a lot of code reviews. So I would say I review more code than I write code these days. But I also have a quite long experience in developing proprietary software. You have to make money for a living after all, right? And I did a lot of things also, from high performance computing, computer vision stuff to low power mobile apps. So I'm just interested in quite a lot of stuff. I'm an automation freak, I would say. I hate doing things manually, like setting up developers' machines or anything like that. And yeah, because of that, I do like ideas like configuration as code and so on. What personally motivates me is to get out the process pain of software development. So in proprietary software development, you have to follow a lot of processes, and that's not really fun for many engineers, right? You just want to code. I also want to bridge the gap between open source and proprietary software development, because to me, it's really sometimes sad to hear that, you know, these two parties are fighting each other and don't really like each other. Either you're a fully open source guy and you use Linux as an operating system, or you are the evil commercial guy. And this is something I'm trying to relax a bit. And as part of that, I'm also trying to advocate for an open and transparent engineering culture. So I'm also interested in things like inner source and open by default, searchable code, sharing knowledge, all that stuff. So, talking about motivation, what is the motivation for this talk then? I don't know how many of you are perfectly clear about what the actual problem is that we're trying to solve, but I decided to give you a very brief overview over the problem statement, right? So in a nutshell, what's the problem after all? So suppose you're developing an application, right? And that application is very likely to have dependencies in the form of libraries, and I have two direct dependencies here, library 1 and 2. And these libraries are also very likely to have dependencies themselves, right? Transitive dependencies from library 1.1 to library 2.2 in this example. And each of these actually come with a license, or that they should come with a license, right? If something is not licensed at all and you don't find a license, default rule, don't use it. So in this example, everything is licensed somehow. Your application that you're developing in your commercial company is proprietary licensed. Then the two example direct dependencies are Apache 2 and EPL1 licensed, and then for the transitive dependencies, I chose some rather common and simple and unproblematic permissive licenses. So, okay, looks good, maybe, right? No GPL in there, so everybody knows GPL. GPL is bad, right, for commercial software development. No GPL in here, so all is good, right? Probably not. Luckily, there are pages like TLDR Legal, which give you some idea about what you can and cannot do with licenses and what you must do if you use software components that are licensed under that license. So at the example of the two direct dependencies, let's have a look at the Apache 2 license. What can I do? I can use it for commercial use. I can modify it, distribute it, blah, blah. Okay, looks good. What can I not do? I cannot hold the party liable that is creating the library. Okay, I cannot use it as a trademark. Yeah, sounds good. What must I do? I must include the copyright, the license, state any changes that I'm doing to the dependency, and include a notice. Sounds doable, right? Even for a commercial project. Then let's have a look at the EPL. It looks quite similar, but the must column is slightly different. So you see, or maybe you don't see if it's too small, apologies for that. I have to disclose the source. Oh, wait a second, that's bad, right? Does that mean if I use a dependency that is licensed under EPL 1, I have to disclose the source code of my own application? Could be, right? It's a bit unclear. So if I unfold this disclose source arrow, some more details appear. So on TLDR Legal, which by the way is operated by a company called Fossa, which also do their own open source compliance tooling, they describe the disclose source tag as, it describes whether you must disclose your source code when you distribute the software. Okay, that's now really bad, right? If I use EPL dependencies in my commercial software, reading that, it would mean I need to disclose the source code of my application, of my commercial application, which is probably not what you want to do. But then, digging a bit deeper, looking at the dependency heaven block, which is, by the way, also a block operated by Fossa, it's the same company, right? They say in their OSS licenses 101, under the EPL, if you simply use rather than modify an EPL license component and keep it in a separate file, like a jar dependency that you're referring to, that would not constitute as derivative work, and you would not be required to make available your source code. Yes, so that sounds doable, right? Bottom line, it's tricky. You have to look at the fine print. You might get different answers depending on who you're asking, even within the same company, as we saw here, and even across different lawyers that you're talking to. It's really a mess, right? And that is one of the reasons why there is no common rule how to deal with these things. Some other common misbeliefs that I have to deal with on a more or less daily basis. people are often under the opinion, especially developers, that caring about your direct dependencies is enough, right? Because, well, transitive dependencies are under the responsibility of the one who's creating that transitive dependency, right? So if they claim that dependency is whatever Apache licensed, and they are wrong for whatever reason, it's their fault, right? No. If you are the one who's distributing the software, and you are the one creating the mix, and you are the one pulling at the dependency, for example, by statically linking or building a fat jar or building a war container that you're running inside of Tomcat or whatever, or even worst case scenario, you're creating a Docker image, which is a whole other can of worms, then you are the one distributing the transitive dependency, and you are liable for what is happening in there license-wise. Similarly, relying on the declared license is sufficient, right? Again, at the Maven example, because it's probably known to most of you, Maven allows you to declare licenses as part of the POM, right? In the POM metadata, there's an XML tag, and you can write in the license name in there. And suppose that license is wrong for whatever reason, right? Or not complete, at least. Whose fault is it? Is it the one who claimed the declared license to be correct? Again, it's your fault. If you rely on that information without double checking and putting in best effort, like using a license scanner to scan the source code to discover additional licenses, it's your fault. You will be liable. And finally, all this is not about some crazy company policies, you know, boring stuff that companies come up with to burn your working hours or anything like that. It's simply about German law, right? It's the Urheberrecht. You have to follow German law in order to distribute software. This is getting complex, right? So I'm an automation freak. I don't want to deal with all this. I cannot remember all of the rules. Please give me some tools. Right? And this is where it all began. So back in 2016, I was still working at a company called Here Technologies, which was split from Nokia. And due to the split, we had no commercial tools available anymore to do open source compliance. So we started an evaluation of the tools back then. All the usual known suspects, you know, right? Black Duck and Flexera, Palamida, White Source, whatever, right? And some of the tools that exist now didn't exist back then, but anyway. What we found out back then, not everything might be correct anymore, but back then we found no suitable tools for CICD in general. The whole idea of CICD was not super new even back then, but it didn't reach the commercial vendors yet, apparently. Okay. As usual, there was no single good fit for all requirements, right? That's a common problem. But on the technical side, even worse, the dependencies often were not correct. Either only direct dependencies were reported, or for whatever reason, they were at least not fully transitive. Concepts like scopes were not supported, so it's a clear difference, right? Again, at the Maven example, if you use a build time dependency, compile time dependency, or a test dependency, because these might be distributed differently. And again, distribution is the trigger for all of these obligations. So you have to know the scope of your dependencies. And finally, things like version conflict resolution were often not considered. So what is version conflict resolution? If you have, again, Maven as a build system, which only allows you to have a single dependency in one version in your project, there are different programming languages that have different concepts, but for Maven, it's like that. And then for some reason in your transitive dependency tree, you have the same dependency in two different versions. Then you have to align on one of the versions. That is version conflict resolution. And if you do things like statically parsing your XML files or so, then you don't get version conflict resolution. At least you don't get it in the same way as the build system would apply it at build time, right? And that can make a difference. We had cases where it made a severe difference in license findings. Commercial tools often are not configurable enough. For example, regarding policy rules, different companies have very different opinions about what checks should be performed and about configuring your attribution documents, for example, regarding the formatting, the layout, the content, basically everything. But we were also looking at open source tools back then already. But for the commercial tools, at least, you have the typical problems of commercial tooling, like a vendor login, and it's a black box, right? You put something in, you get something out, and you have no clue how the tool came to that conclusion, usually. So that's why we decided to build our own tooling. However, we did not want to reinvent the wheel, right? We instead wanted to fill the gaps between the tools, something like the glue code between existing tools to make them interoperable. And we wanted to do this by abstracting away the underlying tools to ease the comparison between the tools and also ease migration, right? Because migration is also a big problem. If a company decides to, whatever, switch from Black Duck to FOSS-ID, for example, I know a very concrete case, it took them literally years to do that migration, right, across the whole company. And that was because of the tight integration with the tools. If you first abstract away the integration and then switch the tool underneath, right, then you have far fewer problems. Yeah, in the spirit of the Unix philosophy, we wanted to do one thing and do it well, right? In German, we would say we didn't want to invent the eierlegende Wollmilchsau, right? It shouldn't do everything, but exactly what we needed it to do, or split it down in separate tools, and each tool does something very specific. It should run equally well on CI and locally, because that is important for reproducibility, right? If a developer just sees some CI pipeline going red and compliance alert, whatever, and you have no clue why the heck is this happening, right? You want to run this locally and try it out and understand what's happening. We wanted to have a human-readable result format, but it should also be machine readable to some extent, and we ended up using YAML. I spoiling a bit, and yeah, the results should be comprehensible and reproducible. The first prototype was in fact a collection of scripts per language and package manager. So for Java, I was writing something in Ruby, Groovy, and for Ruby, I was writing some scripts, Ruby scripts that called bundler and so on, right? And for proof of concept, that worked out. So the results were promising. So the decision was made to rewrite it as a unified tool. And this is also a question I get asked many times: why the heck Kotlin, right? In 2016 or 17, more or less. Well, that was more or less a fun decision, because back then I was working at the CTO, the Chief Technology Office, and we also experimented a bit with new technologies and everything. And I thought, well, if I have to start a new project, then let's add some spice and use a new programming language back then, right? So it was Kotlin. Because I personally like the JVM as a platform, but I don't like Java. So yeah, I gave Kotlin a try. So, and this is what became the OSS Review Toolkit, or ORT for short, which is a suite of tools that aims to assist with the task or the tasks that commonly need to be performed in the context of license compliance checks for applications. Right? I'm stressing applications here a bit because there are other problems like compliance checks for whole Linux distributions, compliance checks for Docker images, and so on. And we are all aware of that in the ORT core development team. But this is not the primary focus of ORT. The primary focus of ORT is doing compliance checks for applications. Right? Docker compliance would be a whole different topic, maybe next time. By now, I'm very happy that ORT is being used by several rather big companies like Bosch, of course, BMW, Daimler, EPAM, HERE Technologies also, of course, and Porsche is becoming a big contributor to ORT, which is quite nice. The scope of ORT is also being continuously extended. So originally, we focused on open source compliance, meaning open source licenses. But in fact, if you think about it, it's only about licenses and their obligations. So you don't really care whether is it an open source license or is it a commercial license. Also, commercial licenses have obligations that you can put into rules. So we can also do commercial license management with ORT. And of course, security is also a topic. And it turns out that with the same metadata that we gather in the ORT analyzer, for example, you can do simple security vulnerability checks. Export control is another topic. Okay. Let me briefly go over the architecture and repeating a bit what the intention, the goal is and the resulting workflow. We want to highly automate open source compliance checks. I say highly because fully will never be possible. There are always edge cases where a human needs to look at. Which means in the end we need to fulfill open source license obligations, and these typically are redistribution of source code, attribution to copyright holders, and ensuring license compatibility. In order to do that, we need to analyze what the dependencies are. And once we found that out, we need to find out where the source code is located. We need to download the source code. We need to scan the source code in some means with some sort of scanner. I will come to that later. With licensed copyright scanner, we need to be aware that declared versus detected licenses, there might be a problem, right? There might be a mismatch. It's different things. We need to evaluate some rules on top of the metadata. And finally, we need to report about the outcome in the form of like a software bill of material or some other report formats. And this leads us to the fundamental ORT building blocks. There are more tools, more blocks by now, but these are the fundamental tools. There's the analyzer, which essentially is a software composition analysis tool. The downloader is a rather simple tool. I'll skip over that. It's basically curl for VCS systems, so you don't have to deal with whether the source code is hosted in Git or Mercurial or Subversion or whatever. The scanner is actually a wrapper around scanner tools. Again, right, we don't want to reinvent the wheel, but standing on the shoulders of giants, and we make use of existing scanners here. The evaluator to implement the rules, and the reporter tool to create the attribution documents and assets, also like source code bundles, etc. Taking a look at the analyzer in depth. So to start, we decided to have some specific design decisions here. We wanted to inspect projects from the outside, right? Of course, as you know, there are many tools, or most are often build system plugins that can report about dependencies, right? You can just say Maven dependency tree, boom, done, right? Yes, for Maven, that's more or less true, but the important bit was we wanted to be able to analyze projects that are not under our control, right? We can't tell some arbitrary open source maintainer, hey, we want to analyze your project and please apply that build system plugin for us so we can analyze your project. They won't do that, right? And also within your own company, there will certainly be some pushback if for the whatever nth amount of time you're asking the development teams to apply yet another build system plugin because you have to perform these nasty compliance checks. So that was one design goal. We also wanted to gather as much data as we can and filter later. So we didn't want to restrict us to begin with to only look at what is needed for a specific use case, but we wanted to first collect everything and then filter down the data to the specific use case. So then if the use case changes, like you're distributing to another country or whatever, then you just have to refilter the data without scanning again. We wanted to take version conflict resolution and all those nasty details into account, which is something I talked about earlier. And yeah, so we ended up with an analyzer that by now supports about 20 different package managers, including the more popular ones like Gradle, Maven, NPM, Yarn, and so on. And we also have a fallback implemented for cases where there is no dedicated package manager, like some low-level C++ stuff, where you can use SPDX documents to declare the metadata that we need in a machine-readable format. This is roughly, I hope it's readable, how the YAML output of the analyzer looks like. So for this Commons text package from Apache Commons, we collect the authors, the declared licenses, description homepage, location of binary and source artifacts, and so on. So this is just FYI, basically, so that you have a rough feeling about what the analyzer collects. Plus, of course, the whole dependency graph, which doesn't fit in here. I'll skip over the downloader because it's really just an internal tool that's programmatically used by the scanner. And the scanner, like I said earlier, is not a scanner itself. It's an abstraction layer, and it wraps around any configured scanner. Right now, we support ScanCode, Licensee, and Escalono, which is more or less a hobby tool from an Amazon employee as license scanners. And then we also have the so-called snippet scanners. So maybe I can go roughly into what's the difference between the two, right? License scanners are rather simple tools, right? In a nutshell, they grab for license headers in source code. Snippet scanners, on the other hand, are fingerprinting the source code and trying to discover copied code snippets. So that's the fundamental difference. And if you know where a code snippet comes from, then you can go upstream and look in the upstream project, what is the declared license for that project, at least. So that's the rough difference between those scanners, and we support both types. Again, the YAML for a scan result, and all of these YAML fragments get amended in the ORT result file. So it's basically not one result per tool, but it's more like a pipeline, right? So the output of the first step becomes the input of the next step, and then the result is amended throughout the whole pipeline, so that in the end you have a big document that comes up with all the metadata, everything we know about the project. The Variator. The Variator is a very generic tool in ORT. It's basically a freely programmable rule engine via Kotlin DSL, right? We are Kotlin fans, like I said, so we even migrated our build system, which is Gradle, from Groovy script to Kotlin, and of course we had to use Kotlin script then also for the rules DSL. And from that DSL, you have full access to all metadata of an ORT result, which is basically what you saw earlier in those YAML snippets. Which means you can essentially perform any check that you want, right? So you're not at all limited to open source compliance-related checks. You can also do security-related checks or anything crazy. I don't know. You could check how many stars a project has on GitHub, and if it has fewer than 100 stars, you issue a warning that is probably not well maintained or popular enough to be taken into commercial use, whatever, right? In addition to the code written in the rules DSL, the evaluator also makes use of license classifications. So maybe you know these very coarse classifications in permissive licenses, strong, weak, copyleft, and so on. You can do that, right? But in my opinion, it's not very meaningful because it doesn't really tell you what you need to do, what you need to look out for. So a better approach is not to use those coarse classifications, but to use classifications that are based on obligations. So label all the licenses in your classifications that require attribution. And label all the licenses in your classification that require to disclose the source code or whatever, right? And based on those more fine granular obligations, it's much easier to implement meaningful checks. This is again a code snippet from the DSL. Not super telling, it's just again FYI, so that you get a rough feeling about how this looks like. It's a super simple check, a naive check about whether there's a copyleft license in the source code. The reporter, one of the most important components probably when it comes to users of ORT, because this is where you get all the documents that you need to add to your distribution, right? So the reporter can create nicely themed, company branded PDF attribution documents. We do this via free marker templated ASCII doc documents, which means you can create any format that ASCII doc can generate. We can generate classic notice files, as known from the Apache Foundation projects. We can generate simple static HTML reports, more sophisticated dynamic HTML reports with some interaction possible. We can create Excel sheets, which makes legal happy, right? And we can generate SBOM formats like SPDX, CycloneDX, or Control-X automation, which was a format that I didn't know before, but apparently some Bosch units are using it, and it's even open source, the schema specification at least, so I was fine implementing it. And we can also output some more specialized JSON for further processing, like a special evaluated model where basically all the rules and everything is pre-baked and you don't have to apply it on the fly. And we can output JSON for use with GitLab. Because you might know that at least the GitLab Ultimate Edition, I believe it is, has built-in license management. And by default, they are using License Finder, I believe, as a tool. But with this, you can use ORT instead. All of these, or almost all of these, additionally support format-specific options so that you can fine-tune and tweak the outputs. This, again, is just a very simple screenshot from the web app reporter. It's really trivially small, but to give you a very rough idea how it's looking like. And then I was talking about CICD in the beginning. So on short notice, I decided to not give an interactive demo, so sorry for that. You only get a screenshot, but if you're interested in interactive stuff, you can reach out to me after the talk and we can take a look at how it's looking at interactively. But we have several integrations committed to the open source repository of ORT. One of the integrations is a simple Jenkins pipeline. It's a declarative pipeline that is making use of Docker build steps that in turn use the Docker file of ORT to run all the different stages. And here again is just a static screenshot of how it looks like when scanning a super small Maven project that we're using ourselves in ORT, which is called Semver4j. And as you can see, everything is green except the evaluator stage, which is because we have an artificial rule violation built in here to demonstrate how it's working and looking like. And then not too long ago, I was very happy that there was a contribution from Google to ORT adding Tekton integration. I didn't know Tekton before, to be honest, but it's a Kubernetes native CICD platform. And they were contributing some configuration to run this Tekton pipeline on Google Kubernetes engine. So besides that, I know there are a few companies who run ORT inside of Azure pipelines, for example, but the pipeline definition is not public for that. And I believe here technologies are still running it on AWS. So it's working to run ORT in a pipeline in CICD or in Kubernetes. So as we're approaching the end, some outlook. I sort of spoiled this before, or maybe those with sharp eyes discovered the stage in the pipeline screenshot just a few seconds ago. By now there's a new ORT tool called the Advisor, and it's able to advise about security vulnerabilities or also defects, or sorry, there is a typo in defects. It's a classic Kotlin typo because there is a static code analysis tool called like that in Kotlin. So yeah. And again, we are not implementing security vulnerability checks ourselves, but we are making use of different providers, and currently implemented our Nexus IQ from Sonatype, the OSS index also from Sonatype, Vulnerable Code, which is an open source project run by the same people behind ScanCode. It's a company called NextB, which we're very closely working with. And just recently, we also added the Google OSV as an advisor. So if you enable that, you get CVE reports about any known security vulnerabilities in your software components that you're using. It's not a static code analysis security tool, right? That's a different story, right? This is about known security vulnerabilities where CVEs are being filed for. Of course, you could also scan your source code for common code patterns that lead to security risks, but that's a different story. But it would fit to the advisor in general, so something that we could do. Pretty much everything in ORD is non-UI, which makes ORD a bit hard to set up and operate for non-engineers. And especially as we have a growing number of legal people or people that do license curations and that kind of stuff, we needed some sort of UI. And there was an early experiment started as a hobby project from one of the core contributors to ORD, which is called the ORD Workbench. The ORD Workbench is an interactive tool that can also write to ORD configuration, basically, right? So all the other reports, they are basically read-only. You can interactively scroll through the reports and expand and collapse things and search and so on, but they are read-only. But what if you wanted to right-click on something and say, ignore this license finding for whatever reason? So that is something that will come in the ORD Workbench. And the ORD Workbench, in turn, is a sort of intermediate step towards the ORD server that will be coming. So we are planning to rewrite the front end of ORD and create a backend that is a real server front and backend thing. So you have a UI, a web server to go to, similar to tools like Force ID or Snook or whatever you're using. But that's a rather big effort, and work, real coding work besides conceptual work has not started yet. Yeah. And that concludes the talk.
Thank you very much for this interesting introduction, Sebastian. And yeah, now we have time for questions. There's one at the back. Please do wait for me with a microphone so that everybody can hear.
So thank you very much for your presentation. Now that you described or explained that even the transitive dependencies can have a consequence for your project, if I don't have a very complex project where I don't necessarily want to use this nice tool, is there a way where I could look up one particular direct dependency of mine and see if any of its transitive dependencies is, let's say, of some kind of concern?
That very much depends on the exact language and build system you're using. So there are very different and specialized tools available for Maven, for example, or for NPM or for other languages. So, I mean, yes, of course. I mean, the easiest thing you could do for a Maven project is look at your own POM. That's where your direct dependencies are listed. And then look up on sites like mavenrepository.org or so what the licenses of your transitive dependencies are. Or even look at GitHub itself, right? If I mean, that doesn't apply to commercial software, but for the transitive dependencies whose source code is hosted on GitHub, GitHub has also this Insights tab where dependencies are listed, but only for a very small number of supported languages. So it really depends a lot on what language you're using, what build system you're using, what's the best way to get this information. Yeah.
Thank you for the presentation and for making the software open source as well. My question is, do you know how your software compares to commercial software?
To be honest, we don't know in all detail. That is exactly one of the things we want to do in a more formalized way, right? To have a real gold standard, something like a repository with known findings, and then you run different tools on it and look which tool is finding what. But occasionally we do, of course, comparisons with not only commercial tooling, but also other open source tools. And especially regarding the analyzer, our experience is that ORT is the best, of course, right? No, honestly, of course, we discover problems, but we are very eager to fix them very quickly because we are, very eager to get this right. And I know we do get it right in many places where others don't get it right, especially Google is maybe an example, right? What's the name again? This tool from Google? No, sorry, not Google. It was GitHub. This Dependabot, yeah, GitHub's Dependabot. So they acquired Dependabot a while ago, which is a tool to discover your dependencies in order to tell you whether there are updates. And if you look at the source code of Dependabot and how they are, for example, parsing Gradle build files. Gradle build files are written in a DSL. It's a programming language. It's not a declarative language or markup language like XML or something. But what they do is they parse these files with regex. So that doesn't work, right? You need to execute the code to understand what's happening underneath and to take things like version conflict resolution and forcing of versions that Gradle can do into account. And as far as I know, ORT is the only tool that can do that from the outside, at least. There are other plugins, of course, for Gradle that do exactly the same, but if you also have this requirement to analyze the project from the outside without applying plugins, then as far as I know, ORT Analyzer is the only project that can do it.
Thank you for maintaining that great project. And one question I have is, so I learned that the project outputs all my obligations as a summary, but on the same time I learned that there are some confusions how to interpret those licenses. So there must be some kind of definition, and who maintains those definitions? Are there ongoing discussions? And can I believe that, or do I have a look at those rules for myself in order to be sure?
Yeah, thank you. That's a very good question that I didn't cover in the talk. So a very important aspect of ORT is we don't do legal advice, right? We are just engineers that write a tool. So there is no legal advice anywhere in ORT's code base. There are some example rules which are super trivial, but we don't come with an out-of-the-box configuration for ORT that sets you up all the pipeline and you're done, right? And everything is fine. And that's, of course, because we are not attorneys, we're not lawyers, and also because the attorneys are not, they don't agree on German law, for example, right? So the different attorneys in different companies have different opinions about how to treat the same license. That is also why ORT is so configurable, because you can just implement whatever you think is right, right? But that clearly is a problem, because it also hinders you to set up ORT more quickly, right? It's a pain to set up, especially from the configuration perspective, because you first have to talk to your lawyers, get out of them in some, programmer understandable way what they want, right? Put this into rules and then make it all work. But or maybe one more funny thing first. So many of these companies, they don't have so specialized legal people and attorneys inside the company. So they consult external attorneys. And those external attorneys in Germany are basically always the two same guys, right? And these two same guys over and over do the same conclusions for the different companies. And they probably make a lot of money with selling the same conclusion to X companies, right? But we're talking directly to those lawyers to come up with, some, attorney A approved configuration for ORT so that you don't have to reinvent the configuration stuff all over again. Yeah.
Okay, Sebastian, so thanks for the talk. Also, thanks for creating ORT, and thanks for having 42 slides. I think that's really cool. I actually have two questions. One is, of course, to get it out of the way, do you use ORT on ORT? And the second question is, I mean, maybe people are here who basically know, okay, there is issues around open source licenses, but maybe don't do it very systematically in their company, and are now thinking, okay, if I want to get started on Monday, and maybe not do a full-blown company, you know, change the marketing direction, but how can I small scale start introducing these kinds of checks? What would you recommend from your experience?
Okay, ORT on ORT is a good topic. Of course, we did that in the beginning. I'm a big fan of dogfooding your own stuff. And that is, by the way, also some of the praise we're getting from people using ORT, because they feel that we are using ORT ourselves. ORT is very actively developed. We have no day with no commits, and we have rolling releases because we are just too busy with developing to do releases. Again, the topic of automation, of course, yes, I know. But back on topic, so we recently stopped for too long to scan ORT with ORT. We don't do that on a daily basis, and we need to set up some sort of cron job to do that again. Scanning ORT with ORT is a special pain because of course we have many test assets in there that are deliberately wrong, right? And that have all kinds of problems, and we can configure all that away and make it all nice, but we simply didn't spend our time doing that. But yes, you're right, we should definitely have a badge, scan ORT with ORT, and some better example outputs, nicely themed attribution documents for ORT itself, and all that will come. Yeah. Coming to a recommendation how to maybe take ORT into use. Well, the easiest thing I believe is indeed to just load this Jenkins file. If you have a Jenkins, everybody basically has a Jenkins to play with around, then just load the Jenkins file. Try to run the pipeline by filling out the job parameters and try to get an understanding of how it works. And then, if you're really planning to take ORT into use in your company and you're trying to convince people that ORT is a nice tool, you should probably contribute integrations with your existing tooling to ORT, right? So the first step is always abstract away your existing tooling, and then you're open to switch to anything else that ORT supports, right? And I think that's a good approach.
All right, maybe time for one more question. Yes.
So thank you. Good question with the getting started. I have one question. Could you expand a little bit on the aspect of the context? You said this is for applications. Is that like, I mean, you could have a distributed binary, you could have a web application with a single page front end, you could have a IoT application somewhere at the customer, you could sell the IoT application, whatever.
Yeah, absolutely. So the basic input for ORT by design is the source code of the application that you want to distribute. And there are other approaches and other existing tools that work differently. They basically come exactly from the other end. They take the binary you're distributing and trying to reverse engineer what went into the binary, right? That's a perfectly doable approach, but it has different problems, right? And we simply decided that we want to tackle application compliance first, where you have access to the source code. It was more or less a design decision to do it that way. Yeah, and I mean, like embedded applications, IoT applications, where you might have firmware images or so, it's basically the same problem, right? You don't have the source code, you have a firmware image or you have a Docker image, and you somehow need to reverse engineer. It's simply a different problem scenario, right? I'm not saying that this will never be something that's supported by ORT, but at least you wouldn't need the analyzer then, but you need maybe some other first tool in this pipeline stage. something like a whatever, reverse engineerer or something, but there are tools like Bang and Quartermaster is still active, I believe, and so on. And again, we didn't want to reinvent the wheel, so I believe for these use cases there might be tools that are better than ORT. And I would rather look for an integration into ORT than reinventing the same in ORT again. Did that answer your question?
Yeah, I was just thinking, if you have like an API you provide to somebody else, you have different obligations and the licenses are different, or the obligations you have, as if you distribute a binary of your code to people that they use.
I mean, what you could always do is, even for a binary, if you for some reason know what went into the binary, you could craft an SPDX document and use that SPDX document as an input to the analyzer. And that's a low-level way of telling ORT what's in the binary, but it would work. But regarding the API, you're correct, and that is something that will come in the ORT server backend, where you can basically push your dependencies, if known, right, to ORT, and then all the further processing, like the evaluation of rules and report generation, just triples through, and you can benefit all from all the succeeding stages, basically. Yeah.
Okay, I would say in the interest of time, we should stop the official discussion session here and head outside for coffee and I'm sure many more interesting discussions. So for now, once again, thank you very much, Sebastian, for coming here to tell us about the toolkit.
Thank you.